Great to be here to talk about building Gen AI apps and Copilots and streaming data with Flink SQL today. It's a topic we're hugely passionate about. And yeah, as you all know, generally helpful AI assistants kind of came a long way, all since the 90s. Some of you might still remember Clippy that was part of Microsoft Office. And obviously, it's an order of magnitude different today with a lot of people using ChatGPT by OpenAI or Anthropic Claude in their daily lives, improving their lives for different use cases in a private and in a professional context. Also, especially developers have broadly adopted coding assistants like GitHub, Copilot, or Cursor to become more productive. I think that's also something that a lot of you can relate to. And what we've seen at the same time is that AI assistants have not been as broadly adopted in the enterprise yet. So one reason for that is that AI assistants need to be grounded in enterprises' own data in order to be of value. And this is obviously a hard problem, because data, especially in the enterprise context, is always a difficult subject. And especially since also some of that data, as you know, is real-time data. So the Copilot needs to understand both streaming and batch data in order to be of value for the user of the Copilot. And we're trying to push that forward, especially with the streaming capabilities, because we really believe that data streaming has a place in this, especially kind of being an ideal technology to bring together basically the world of data streaming and AI. And this is what we're trying to do with Copilots, because we believe they have the power to connect the operational and the analytical state of a company. So think of the operational part. So the databases you have driving your business, all the events continuously being produced, often traveling through Kafka. And then you might have a stream processing engine like Apache Flink in order to aggregate that data, make sense of that data, put it somewhere else, put it to use. For example, in an Apache Iceberg open table format on object storage. And then this can power your analytical use cases, like your dashboards, BI tools, or even machine learning applications. And then the Copilot in itself becomes valuable because it can have access to all of these systems. It can dive into Kafka topics. It can basically utilize Apache Flink stream processing as a very powerful tool that is normally not available in tools like ChatGPT. And obviously, it has also access to all your historic data that might sit in the data lake on object storage, and of course, also to the other data sources you might have across the organization. And then a Copilot is also something that can not only look back, but it might also help basically run your business moving forward. So by having a natural language interface to set up workflows that can dynamically be generated in order to process events, take action when something happens across the organization. Now let's look into it. Copilots can, as I said, be a new interface to explore and work with streaming data. So let's say, for example, a business user would ask a question like, what is your revenue today in stores per product category per business hour? And this data is nowhere materialized in the organization yet, but we would, in this case, apply a stream processing job to dynamically aggregate the data and display it back to the user. And then the user might ask, can you please give me updates for this for the next 2 days? And we could basically, from that input, create a workflow where we say, for the next 2 days, we send the user continuously updated information about a specific query. So this just shows, as an example, the power this technology actually has, not only for technical users, but also to bridge the gap towards business users within an organization. And this is kind of the core of my talk today, trying to explain to you a bit how specifically Copilots can be used not only for technical users as a tool to make them more productive, but also for business users within an organization. Now, let's look a bit deeper what actually happens under the hood of this. So there is a Copilot user asking a question in natural language. This gets sent to the Airy Copilot in this case, and the Copilot might just ask a vector database. So do classical retrieval augmented generation. Look for vector embeddings and give back the response in case there is something that matches the query. And actually, most demos end here. And this is totally valuable, of course, because continuously generating these embeddings is obviously a necessary task, especially for the vast amounts of unstructured data that enterprises still have and are underutilized today. But actually, the potential goes far beyond that. So we really believe that the biggest potential is actually in looking up data that is not stored as embeddings, especially for data that is like soon to be outdated. Yeah? If you, for example, imagine about the revenue today, you wouldn't store that in a vector database because it would be immediately outdated in the moment you store it. In that regard, for the vector database, context is very important. In what context, basically, an information is true. And it needs to be combined with structured data that might sit in a data warehouse, a data lake, or even in a stream, because it's so fresh that you basically need to make sure that you always have the freshest data in order to give an accurate response. So an Airy Copilot, in this case, would be able to generate SQL, ideally with the context on the data, and give that SQL to a stream processing engine like Apache Flink. And then Flink could kind of execute that statement and read data from, let's say, real-time data streams or also from data lakes powered by data catalogs. Then as a next step, the Copilot would decide which model to use and then run the relevant model so that the stream processing engine can produce, let's say, text generation, embeddings, or even predictions about the future, in case you have a matching machine learning model that can give you a meaningful prediction. Then the answer is sent back to the Copilot user, ideally rated with a positive feedback saying, okay, this was what I expected. Sometimes you need several iterative tasks to get where you want it, but we believe that this technology can be really powerful, especially for data that should not be stored in a vector database, but that should be combined in terms of structured and unstructured data in order to create the highest value for the Copilot user. So a very important step, as I mentioned, in this regard is pre-processing. So selecting the right data integration strategy on the level of the Copilot. So what we do there is we look very much on the semantics of a question that a Copilot user asks. In this case, you have, for example, words like today or right now, indicating that the data you're looking for is tabular real-time data. Yeah, so maybe sitting in a Kafka stream with retention periods of 48 hours to 7 days. That's also something that obviously the Copilot needs to take into account how long the retention window, for example, of a Kafka topic is. Then you have maybe tabular data that is historic, that sits in your data lake. Like, for example, if you need data from the last 3 quarters because the user asked a question in that regard, you need to kind of provide context regarding an iceberg table, for example, that sits in a different catalog. So you basically have to adapt your strategy on the fly, what data to query. And then, as I mentioned, you could also have, for example, predictive models sitting in Google Vertex AI, and then as a model registry, you basically need to pick the right model that is capable of answering this question when a user asks, for example, about a prediction for the next quarter. So you can actually match that and run the Vertex model and then infer the data as a result. And of course, you always have RAG, searching for unstructured data, as a universal fallback strategy, which is always available, which we run normally in parallel. And in case we don't see that this is actually leading to a meaningful response. But what is the key behind all of it? The key, from our perspective, to data intelligence is generating semantic understanding of data. And this is really an area where large language models excel because this is what they're really good at. Yeah? Language, yeah? The patterns that you see within language, within different languages, basically being a universal interface between a human expressing their need, their intents in natural language, and the data that obviously is stored in a different format. And you can have foundational models like language models, text-to-SQL models, as a very powerful tool to actually make that data more accessible to human users. The way we do that is there are a few steps that you need to do before in order to be prepared. So this is happening asynchronously. This is not happening at inference, but you can actually do that once you connect the data to the system. It's very important to look at, for example, data catalogs and schema registries that you have within your organization and annotate your schemas. Because what we normally see is often these schemas are not perfectly annotated. Comments are missing. You have basically just weird names of the columns in practice because, yes, people are busy and they rarely invest enough time in documentation. And that often is not a problem for human users because human users have something called human intuition. But a machine, obviously, as you can relate to AI, doesn't have that. So for AI, it's crucial that basically these data properties, data assets are perfectly commented, annotated in order to understand what a human actually would mean, especially when they're not using exactly the same words as basically described in the name of the field, for example. So in that regard, what we do here is we heavily use LLMs to generate comments automatically on the fly for the schemas of the data, for example. So we end up with annotated schemas. And then we do one very interesting thing. We utilize something like vector databases because we have that running anyways in our infrastructure. So we use vector databases to index all these annotated schemas. So we make that searchable again. And this way, we actually get a way for AI to understand your data, to use it effectively, which is required in this case, to get to much better results. Here's an example of how this looks like in our product. So what you can see here is the Airy control center. Gives you visibility of all the Kafka topics in this case. It would work the same with Flink tables or any other data catalog. Here you see the schema that is not annotated at all, so just have short product names, and then we ask the LLM to generate more meaningful descriptions for each field and save that as a document, as a comment, basically, for each column and for each field. And yeah, you can basically accept all changes, and then you can run. One very important thing in that regard as well is not only to look at columns and fields, but also looking at tables. Because often, especially when you're in a large organization, you might have hundreds or thousands of tables. So it's also crucial for the LLM to understand what kind of data is inside a specific table, especially if you have, let's say, several tables that might contain similar data or contain similar data out of a different context. Yeah? So transaction, purchases, etc., that could mean the same. So giving the LLM context about what data is included in which table is absolutely crucial. And we would rather err on the side of giving it too much information. Yeah? As you can see here in this example, this is for, let's say, the yellow cab taxi data, you would actually give it a lot of information about what kind of data is included, what users use this data for, what kind of queries are run normally against this table, and what could potentially be use cases for this, yeah? What kind of value this data has included in this table for the organization. And in this case, we use table comments in Flink SQL to store the information. You can, of course, also use different data stores to store that metadata, but we believe that the value of this is immense, especially for the metadata. And then, of course, you can also update this data. You should actually update this data whenever this changes. There's also, at the moment, for example, a small shortcoming in Flink open source. We created a ticket for that already, so suggesting an alter table statement to also make a comment updatable, which is not the case at the moment. The only way to update a comment at the moment in Flink SQL is basically to replace the entire table, which is a bit heavy as an operation when you have, let's say, very large tables and you just want to change the comment for a table. So this is something that we hope will be worked on really soon. And of course, as I mentioned, you have a continuous generation of vector embeddings combined with that. So whenever something changes in the schema, we basically can read from that, take that as a event that changed, and then also apply, in this case, a data pipeline where we would continuously generate vector embeddings. So we have a connector reading those schemas. We automatically generate the embeddings and store them in a vector database. Historically, we've been doing this with our own apps, so just the consumer Kafka streams running perfectly. We've been most recently being part of the Confluent Early Access program for AI inference that actually went live into production yesterday. So we were able to replace, let's say, a very heavy Java app that you saw before that was running this through, let's say, 10 lines of SQL, where you have basically a pipeline where you continuously generate vector embeddings with Flink SQL AI inference That's Flip 437. It's actually already implemented in Confluent Cloud. Hopefully will come soon to Flink as well. So you have actually within this proposal the possibility now to create models and run them within your Flink instance. So in this case, you would create an embedding model with a few lines of code, and then you have a continuous query that actually runs, that calls an API, in this case OpenAI's embeddings API, and then this is connected to a sync connector. So it writes the data into a new Kafka topic, and that is picked up by a sync connector and then syncs it to a vector database. So this is a really, let's say, very agile and still robust integration of a pipeline to continuously generate vector embeddings. Also something we heavily use. Now let's look a bit deeper regarding how does it concretely look like when you build a Copilot powered by data streaming. So obviously you have Kafka. Yeah? We assume that Kafka is running. And you might also have Flink. There is, at the moment, for this Copilot experience to work, there is one caveat. You need to have the SQL gateway enabled, which a lot of people don't have at the moment. But we really would encourage you, even though it allows only to run statement at the moment in session mode, there is an open flip to also enable that for application mode. But it's really interesting, because it gives you a new way to interact with your data. Because you can actually much more easily run SQL statements against your Flink cluster, being not as heavy as normally when you set up a new Flink job. So you can actually experiment with the data much more easy, and this is something that we currently use in the Copilot context quite heavily, because you obviously run much more statements than if you write these Flink SQL queries manually. And that might also be connected, obviously, to your data lakes and to your warehouses, other data stores. And you might also have, for example, already a vector database somewhere in your organization, or you can easily deploy one or use one of the lots of vector database providers. It doesn't really matter which vector database you use. We also often use open source vector databases. So for us, it seems to be every vector database works when you want to do the first steps. And then from there, obviously, you can pick the provider that suits your needs the best. Our core infrastructure is built on Java, but specifically for the Copilot, we actually picked a more lightweight implementation. So everything you can see here is written in TypeScript. So we have actually 5 components that power the system at the moment, which is an LLM controller. That's the entity that talks to the foundation models, mostly externally. Then you have the Copilot backend and the Copilot frontend. This is at the heart of the system, plus the frontend is the user-facing component, UI, a small React app. And then you have, obviously, something that needs to talk to the stream processing engine, which is something we call the Flink connector, consisting out of a statements executor. That's actually reading from a Kafka topic and then calling the SQL gateway within Flink. And then we have also a consumer, which we call a result sender, consumes the results and basically calls the Copilot backend again in order to give back the result. So that's actually a very simple architecture, not too difficult to build. And we believe it's super valuable. So now let's show one example. So now we have a Copilot UI here running, and let's assume a user would ask what topics in the organization contain order data, and would give back a response right away saying, hey, there's order data in the purchases topic. You can ask, for example, any other topic that would contain order data. And this is very fast, as you can see, because it's querying the vector database. Now, let's say we want to describe, for example, the purchases topic. And in this case, it would, for the first time now, run a Flink SQL statement. So here is a lot of detail, because we have developer mode enabled. For a business user, you wouldn't show that much detail. And then you run a Flink SQL statement. Here it's a simple describe statement for the topic, for the table, and you would get back the schema, as you can see. So this is actually a direct way, basically, that you have now to interact with your data via Flink SQL within the conversation interface. And then let's continue to ask, for example, what's the last message in the purchases? Generate a simple select statement. And then we generate the result, which you can see here. So yeah. And then we could also ask, for example, how many orders did we have in the last 24 hours? Again, execute the statement. And we get back a result. Yes, perfect, 2 orders. So let's imagine a couple of days later, you ask the same question again. That's, by the way, the same Copilot. It's just the dark mode enabled. In this case, we would ask again, select from purchases. In this case, we also have the option, there are 2 options, to either ask the question in natural language, have it translated, or if you want to have more control, you can do /exec, and then this would give you direct control to write whatever Flink SQL statement you want to execute. And then, again, because we already asked the same question, describe purchases before, the Copilot will remember that we asked a couple of days earlier the same question, so we don't have to even specify the same SQL. But it will kind of remember what SQL to use based on the history of the conversation, which we aggregate at the moment per user, but that can also be put in the system on an organizational level. And then you have the result here, so we have a few more purchases a couple of days later. And then you can also see here, basically directly in the UI, the Flink jobs it is running, can filter for the running ones, so these are the queries that are continuously running. Yeah, so whenever a new purchase comes in, this would be updated here right away. So the Copilot always has the access to the right data. And then something very important that we also added recently is workspaces, because workspaces is something that we believe is the relevant perspective if you look at, especially for business users. Yeah? So curating smaller entities that we call workspaces actually allows us to provide a much more granular, smaller solution space to the user group. So for example, you would, for a sales team, you would basically be able to curate a sales workspace where you only have access for the data that is relevant to the sales team, and you can actually configure that workspace in a way that it knows about, let's say, specific linguistics and specific queries that are relevant for the sales team. So that's basically a way of making it controllable and in a way to improve the user experience quite tremendously. So one example use case, for example, to make this a bit more concrete is we've been talking for a while now with a multinational retail chain, and they were looking for a Copilot for sourcing teams. So the use case here is, for example, to generate RFPs for new products that they want to introduce. So you could basically say, for example, if they're looking for a list of suppliers of vitamin C, you define some metrics you want to include. The Copilot now would be able to pull all this data together and give you back a response. In this case, which suppliers they should pick for this relevant product based on the data that is accessible to the Copilot. And the potential here is tremendous from our perspective. So it's really, I would say, an order of magnitude in terms of this is 100 times faster and cheaper than with the existing process, because the existing process takes basically a team of 3 or 4 people, 2 weeks, costs about $10,000, and you can actually bring that down to, ideally, if it works out, if everything is perfectly connected, you can bring it down to maybe 20 minutes and to a $15 cost. So this is obviously an order of magnitude better. And this is kind of these are the use cases we're currently looking for, where you can really have a tremendous impact on your organization by making something much easier and faster than it used to be. Now, what is still preventing enterprises from adopting Copilots more heavily? So I think there are 3 big issues at the moment that we currently see that stand in the way of basically the tremendous impact this could have and the status quo. First one is data accuracy and hallucinations. So people just being afraid that the Copilot will give an inaccurate or wrong answer, hallucinate, and basically lead people into the wrong direction. Second one is data security, privacy, governance concerns. So will actually, where will my data go? Will basically will some Copilot user have access to the data of another Copilot user? things that you might not want to have, obviously, spilling over. And then obviously cost is always a concern in terms of, this might be cheap initially, but maybe it's something that will incur a tremendous amount of cost down the road with model training, fine-tuning, and inference costs being attached to it. So now let's look at every single one of these topics. First, I would say it's very important to differentiate that you have different users for this kind of integration. And there's also, let's say, there's no margin for error with business users, because let's look again at the different user groups we have here. So we have backend engineers. Their need is to control infrastructure. They're Java native, like maybe most of you guys. And they're basically happy to control infrastructure and code. Questions they would ask is like, show me all the Kafka topics with more than 1 million messages per hour, or fix this code for me. So the typical use cases you would put today in a Copilot, just that this kind of Copilot has access to all your data. So it has context. It can help you much more easily than ChatGPT to accomplish your goal. But still, if it's maybe slightly wrong, you have enough knowledge and you're happy to debug all issues. Then you have a second user group, data professionals. So their need is mostly managing data and access. They're working in SQL and Python all day, solving data problems and asking questions like, write me a Flink SQL query for this kind of thing, or describe this Flink table to me. So kind of interacting with their data and making aggregations and analysis reports much faster than it used to be. And they can still debug most problems because, if you give them a wrong SQL, they're SQL native and they will be able to fix it. They still save time because they don't have to manually write every line of the SQL query. And then you have business users on the other side. It's really a new user group, that is so far not really in touch with that data at all unless they consume existing dashboards. And the need here is self-serve AI and BI. And there also have been a lot of companies at the moment investing heavily in this space. So there is Databricks with AI BI Genie. There is Snowflake with Cortex Analyst. So it's really about opening up this user group with a next generation product that is kind of really able to help them in a no-code manner to get the data requests fulfilled, self-serve, and in no time in a conversational interface. And business questions these guys would ask is like, who were our fastest growing customers last year? Or who closed the most deals this quarter in my team? And again, they expect 100% accuracy. So you have no margin for error with this user group. So how do you get there? The first thing, I don't know, is actually a very good answer. Because what you should avoid is really like having the Copilot configured in a way that it starts to hallucinate and give you information that is that doesn't exist or is not plausible in any way. So it's much better to basically have clear limitations in place and saying, I can't help you with this problem, than to lead people in the wrong way. So this is, I think, the most important thing we always start with is getting there by making the solution space small and managing the expectations of the user. So again, this is tied into this workspaces topic. So you should actually create smaller workspaces where you say, this is, for example, a Copilot for the sales team. It is only trained and configured to answer sales-related questions. It cannot answer questions about the weather or anything else. It cannot write your marketing plan. It's basically an expert in this area of giving you information about your sales pipeline and about all sales-related questions that might occur. And you need a good, fast answer for. So in this case, you can actually create a new workspace, and you can describe it also to the user what data is included in this within this workspace. Then always trying to give a source, obviously. So whenever you read from a vector database or find information that you can relate to, give the source in order to make this relatable and reproducible to create trust. In a way saying, this is where I got the information from, because then you can actually check if it's a trustworthy source, or if it's basically something you might not be able to trust 100%. Then, of course, very powerful, something that people often forget, you have a conversational interface. So you can actually just ask people. So you can basically ask the user, when they ask a slightly ambiguous question, for example, who were the most successful AEs in our sales team in California, just ask them how they define success. Yeah, and then you can basically, it's much easier for you to build the correct query. Then a technical implementation. One strategy here is to adjust the pre-prompts, model temperature and the rec settings in a way to avoid hallucinations as much as possible. Yeah? So this is also something we can organize on a workspace level. So we could actually give it an instruction saying how certain things are to be interpreted within this workspace. And then, of course, very powerful, we can give it example queries, like you've seen before. Yeah? This describe purchases query is something that the tool could remember, but you could also obviously manually enter specific queries, curate the workspace in this way, also adding example functions, so the workspace will have more context about what to expect from users in terms of natural language questions. Then, of course, you can choose foundation models or compound AI systems with higher reasoning capabilities. So you have, for example, more recently, you have O1 preview announced by OpenAI. So this is a new kind of model that has reasoning capabilities built within. So it takes a bit longer than what you've been used to from GPT-4o, for example. But it has much higher reasoning capabilities in terms of it has a mechanism built in to avoid hallucinations, because it's actually not one request being sent to a foundation model, but it's a sequence of requests, and it tries to basically come up with the best possible response on your behalf. But this is the reason why it also takes a bit longer to execute these queries. But depending on how latency sensitive your use case is, that might be still worth it, depending on the use case. And then, of course, implementing additional post-processing QA capabilities. So, for example, having a response, having QA rules, what is allowed, not allowed, what are certain policies within your organization, and then letting it generate the final response. Second topic, data security, privacy. This is always, I think, one of the most challenging topics when you talk to an enterprise, because it's really important to build trust and making private and secure the new default, kind of. So one way of doing that is obviously by the workspaces we already mentioned. So first of all, every user should have its private workspace where, let's say, only their data is accessible. For example, if you think about GenAI pipelines where you have emails continuously analyzed, this is obviously something that you only want to have access to within your private workspace. You don't want to have other users have access to this kind of information. Also, certain queries you might want to run to analyze things shouldn't kind of be visible to other people in the organization. And then you have, obviously, team workspaces where you can actually collaborate with the team, say, like the example that I gave before with the sales team or the HR team, marketing team, can each have their own workspace, and then you can actually curate those workspaces in a way that you give those workspaces access only to a subset of the data. You select the catalog, the schema, the table, and then this workspace has this information, this data as a context available to it. And then you can also have, of course, sharing. So you can make this accessible with granular permissions to, for example, a business user, yeah, inviting them only for a specific workspace, not for other workspaces. It's kind of obvious. Then very important also as a subject is topic access control. So who has access on which data? What we recommend there is normally not to introduce another access control system, but to rely on what you already have running. So you might have data catalogs or schema registries where you have existing access control things set up. So we would rather recommend to always include this. Also, it is tied into accessing the data. So this is the best place to govern this in that regard. It's also interesting to see now what will happen with Unity Catalog and Polaris just being open sourced by Databricks and Snowflake respectively. So there is, I think it's an interesting time right now to see how this data catalog category will evolve, and it obviously has direct impact to this topic of AI, because the goal here is not only to kind of index and govern data assets, but also to index and govern machine learning models. Then, of course, implementing robust data access request workflows where you have certain users maybe not having access to some data. You can actually inform the owner of that data asset and ask them to grant permission, and then the permission can be granted on a case-by-case basis. And obviously, what's also equally important is monitoring remote data sources for permission changes. One example here would be, for example, if you have an ingestion pipeline including Google Drive or Google Sheets, Google Docs, like monitoring that closely in case a permission changes in one of those systems. Then filtering encryption. We always recommend to write as much metadata as possible and to filter per default when retrieving the data. So the reason for that is like often data is only true or that kind of thing is only true in a relevant context. So the more metadata you write, the more secure it gets because you can actually filter per default on, let's say, individual user level. So this way enabling that, for example, you cannot access the vector embeddings that have been generated on behalf of another user. Then, of course, as an additional layer of security, depending on what kind of data you're dealing with, encryption is always an option. Yeah? So encrypting the topics, you don't have to do that with vector databases because vector databases don't contain the actual data, they just contain vectors pointing to the data, so it's totally sufficient if you encrypt the data, for example, in Iceberg or wherever you store it, like in the long run. Could even encrypt it in the Kafka topic. And then, of course, removing PII wherever possible, so that you don't store user information, credit card information, phone numbers. If it's possible within your use case to get rid of that PII, I would always recommend to get rid of it in the stream. Then model serving, obviously also an important consideration. So at the moment, the dominant consumption for these LLMs is obviously paper token models. So you have closed source and open source providers, OpenAI, Anthropic, for example, and you have a lot of like open source model providers where you can actually consume these models with an API request. So here, just as an example, is a list of all the providers that currently offer Llama 3.170 billion. So it's quite a lot, and they compete on latency at the moment quite heavily, so and on price, obviously. So that's something to take into consideration. How to consume or integrate with a model, because in some use cases it might just not be possible to, let's say, use some of these providers, because let's say when you're a bank or insurance company, it might not be that easy for you to work with one of these providers, so you actually need to think about self-managing open source models, and that's totally doable with tools like VLLM, where you can actually, comes with the base cost, obviously, so it's a couple of $1,000s minimum if you want to run it on GPU infrastructure, but it's totally doable, and we have been doing that before as well. So it's something that obviously makes only sense if you have an increased security and privacy requirement in that regard. Obviously, when you just want to get started and play around with that, it's often much more efficient to use the paper token model APIs, because that rarely incurs any cost. Then making AI systems scalable and efficient is obviously a very important concern in terms of model costs as well. So as you can see here, it's basically, there are quite big differences in terms of the costs that you currently incur when running these models. And often in the beginning, you neglect these topics because it's experimental, not much usage. So it doesn't really matter, but we would really recommend to consider costs from day one to bake that into the value proposition of the POC. Expecting that costs will continue to go down. So you will actually see that, token usage, this is the red column here, the red graph here, and will go up quite a bit because AI usage will simply increase within your organization. So within 2 or 3 years from now, you will have maybe 100x usage from today. At the same time, you will have cost per token going down. So this is something that I think it will continue this way. But this is still, I would say, something to take into consideration, obviously, early on. Another strategy for managing cost effectively, not only cost but also quality, is looking at window sizes. So this is very important because just because there is, let's say, a large model out there that gives you the option to have 500,000 tokens or a million tokens, which with each request, doesn't mean you should actually use that context window, because it will be slow, it will be very expensive, and actually it can, unless you, let's say, you're maybe a law firm that actually has the need to to put a lot of like legal documents in one prompt, it doesn't really make the quality of the response better. Often it actually makes it worse, yeah, because you enter a lot of information that can also lead to ambiguity regarding what is the right answer. So what we always recommend is to optimize the context window sizes in a way that you use as much context as you need in order to give a very meaningful response. And then there are additional strategies like, for example, context caching, which is available in Google Gemini in order to bring costs down. When you have, let's say, a context, a specific context that you often will need or you already know in that moment when you give it to the prompt, that you will need it in the future as well. You can actually cache that and then have much lower inference cost for that specific context. You can always reference it later in a future prompt. And yeah, one important takeaway that we also learned while generating Flink SQL is that context always wins. Yeah. Like the model sizes itself, like 7 billion parameter, 2 billion parameter, 80, 100, didn't really matter that much. For us, it was always like when you give it perfectly annotated schemas, this is what makes a big difference in terms of generating accurate Flink SQL that actually runs flawlessly. So giving it the right amount of context is super important. And data streaming, obviously, is a super powerful tool in that regard to optimize context at inference. Yeah, so to already have that data pre-prepared before the actual query comes, so you can always like have the perfect context attached to the prompt, and then obviously measure for output quality and run this with smaller models and prompts. But this is kind of our takeaway here, that context is the most important thing to optimize for. You will also have down the road more systems that are compound AI systems, yeah, in a way that we're going away now from working with individual models. Also, some users might have difficulties picking the right model. Yeah? So should I use a 7 billion parameter model for this task, or do I have to have the 40 billion parameter model? It's often not obvious to the user. So we will actually move in a phase now where machines will analyze these queries and will make these decisions on your behalf. Yeah. It's also much more efficient this way. And compound AI systems actually are systems that run sequences of steps in order to use different tools, in order to use different dependencies of data within to optimize a most meaningful response. And in this way, we believe that compound AI systems are super crucial in order to having access, for example, to different tools, to different models at the same time, and then being able to pick what is the right system to use, the right model to use for each relevant use case. Yeah? So this is something that will become more and more important. Obviously, it might not look exactly like this within your organization because you don't have to run, obviously, all the models. But in general, we believe that Copilots as a new interface, as I said, are really powerful to explore and work with streaming data, both for the analytical domain and having a lot of potential for the future regarding workflows and agents. We really believe this is kind of where what currently should be adopted, should be kind of experimented with. This is where the technology is really good at the moment. Down the road, it has a lot of potential, So it will be AI agents monitoring data streams, acting on your behalf in the future. So the future is bright. We're very much looking forward to that. But it's really important to start here and now and get the first steps going in order to, utilize AI for data streaming and, utilize the potentials that Copilots have. And we're very much excited about that. And would also like to invite you to really tell us about your use cases that you have for Copilots and AI assistants, both on the technical side, so basically for what use cases you would use as technical users, Copilots as such. Happy to assist you and help you look into your data infrastructure and come up with feasible solutions, but also what are use cases that you currently see potential for also on the business side within your organizations. Would be great if you could let us know. Here is our form that we set up for this talk specifically, so happy to talk and get in touch about the subject. Thank you very much.